want to start with that one biometric system, which is offline signature verification system. Now, the signature itself is a difficult problem. If I tell you to sign a paper, try to sign on a paper, you will be thinking always for what reason you are signing, right. Say for example, I want to withdraw money from the bank, then the signature generally I give is a very long signature. But if I want to write a letter to my friend and there my signature is different, and if I want to keep a copy of a letter in a folder, my signature is completely different. So, generally, so let us consider my case, after that you will find the other case. So, this is the common way I sign, and this signature, first signature is more critical one. Wherever you have the critical operations, we use this type of signature. Say for example, you also do same thing. When you have joined the institute, we told you the sign. So, if when you are doing the critical operations, where the money involves or your entity involves, generally you write the full form, right. Now, I write a letter for my official purpose, I write a letter to my director or dean, or then I write this way. You also will be doing same thing, or you are doing. And this is the very common way of signing. Common way of signing means wherever the importance is less, nobody you by forgery, one cannot gain much, but it is helpful. For example, earlier days in our time, all students MTech and PhD, they have to sign on the register. Nowadays, here you put the card, falana, all those things. So, in the register, and they had the idea that you have to complete the process by 9:30. This is a common practice, and the door will be open at 8:45. It is not that whenever you come and sign the paper, 8:45 and 9:30 that will be closed, and then the register will move to the head of the department, and head of the department generally he uses red ink to mark absent. That absent will be used for your scholarship purpose. That was the standard formula for across the institute. Here also it was there. Nowadays, we are, because it is very difficult to manage such a big class and other things. So, sometimes we used to tell our friends that today I am late, not most of the time, sometimes we used to find I am not going, you why don't do, and so you have to write in such a way that the other person can sign on your behalf. So, generally we used to write the capital letter. Same thing happened with you also. One of you or two of you or some of you have done same mistake, same thing you have done. That student candidate is in quota and father has filled the form, and in the form the father has signed. Now, father does not know the signature of the candidate. Most of them they sign on capital letter. So, after that I remember in 2003, we decided no, it should be running letter, we wrote. But same thing happened, again they are writing the same thing. Then we thought that we will reject some of the candidates. We took the legal help. In that process, I got a signature, which is the signature of Cadbury. The Cadbury has a signature. Have you seen that? Cadbury chocolate. It is there. Cadbury chocolate has signature. So, same signature candidate has given. So, I asked him that this is not your signature. You give your signature. He is telling that it is my signature. So, all those issues came up and we took the legal help. The legal is telling that no, you cannot tell or cannot dictate somebody that you have to sign on this only. Who has, there is no, nothing is written that I cannot sign using capital letter. But if I use the capital letter, my identity is in problem. So, if the candidate wants to take risk of his identity, what is your problem? So, we did not proceed further, we accepted. After that, we have observed that quite a good number of people have started giving the capital letter. Right? Now, capital letter is nothing wrong, but point is that you have to show again the similar way you are writing. So, the student, they started writing only his first two characters. So, it is safe mode. Two character identifying is not a very difficult problem. So, if you see what are the advantages you have using the signatures. Now, the word I have used offline. Offline means that through pen and paper or you are giving your signature or you are proving your identity, not on digital image. So, once you sign it, I have to scan it. After scanning, you will be doing certain operations to get the features. Next time again you have to get the signature and again you do the same process and so on. Now, the problem what we face that if I tell you to sign 3 times at 3 continuously, you will find that there is a variation. If I tell you to sign in the morning and after your hard work, if I tell you to sign again, there is a variation. So, this variation is a big issue and that has created problem for us. So, it is a man-made biometric system. It is not that you are carrying with you, that is you know or you have been told how to sign, you have learned that. So, it is a man-made biometric system. Not only that, forgery part also has been studied well. Now, how this forgery is helping you or I am telling you that it is an advantage. Forgery started means or has been studied well means that it is very easy to learn false acceptance, right. Earlier days if what I do generally in the case of face forgery is not much, because you have to put some mask to prove that you are Mr. X, right. But that is not too many cases you will find, but here the signature you have your aim to forge somebody. It is inherent in our idea that if you see that Mr. X has signed this way, then you also try to learn how to, it is not intentional, you like to see whether you can copy his signature or not, right. And this is habit, this is so forgery on signature has been studied very well and that has helped us to understand what is the false acceptance rate and right in more critically. Now, at the enrollment stage, that if I am an expert, because at the time of enrollment you will be coming, I am an expert to see whether you have forged, that since forgery has been studied well, so it is easy for us to detect whether signature is forged or not. And since it is a simple character type things and training does not take much time, it is fast. Signature is independent of anything, that whether anything means that there is no language dependent. In the case of face, it depends upon the occlusion or reflection, all those properties, but here it is not the case. It is free from any other such type of things. And most important thing is that if you reduce, compress the data, the pattern of the signature retains. See, this is not the case with the fingerprint. If I suppose I have a fingerprint and if I reduce the size, then there is a possibility that you will be missing some of the minutiae points, right. Some of the termination points may be missed, but this will not be the case with the case of, in the case of signature. Is it clear? Now, what are the disadvantages? There are several people now working on forgery, right. And by if you, and there are, we have the habit of earning something without doing much work, that is also inherent in our system. So, if I tell you that if you can forge a signature, possibly you will be getting big amount of money. So, you will put your more effort to forge somebody's signature, so that you can get more money. So, this, and by any means you are through or you have been accepted by your forged signature, then you are becoming very rich, right. So, this has created a problem, and this problem has been well studied. So, as a result, government or any employers, they are not considering this as a biometric system. So, in the case of, say for example, in the case of Aadhaar card, we are not considering signature, we are considering fingerprints or IDs. Now, further in India, scenario is different. With India, 30%, about 30% people, they do not know how to sign. So, this is another big problem, right. And your signature is available everywhere. So, there is a possibility that people can misuse, because of, you know, if I have your signature, I can do lot many digital work on it, right, and I can prove that it is your signature. You have put it on some page which is actually you have not done in reality. Now, there are online signature pad where you can sign the paper. Now, in the online signature pad, issue is it is very fast, it has different dimensions, but it is very costly, the pad is very costly, and moreover that once you are signing on the pad, you are not seeing what you are signing on the pad, you will be seeing the display monitor what you are signing. We are not habituated with that. What we have the habit? We have the habit that wherever I am writing, I am seeing also what I am writing. So, you will be writing here and seeing there, that creates problem, that is the issue. So, all these are disadvantages in the case of signature. Now, what are the things or steps involved in signature biometric system? First one is that you have to, it is an offline signature, so you have to scan it, and then from the scan, it is a page, from the scan you have to extract the certain area where, or ROI, where you have the desired signature. Now, the signature has lot many, you will find that it has a lot of noises and other issues will come, because it may be you have used the color pen, you may have used thick pen, and there are several issues. There is a question of normalization will be coming, because sometimes if I give you the bigger space, your signature will be big, and sometimes if I give you a very small page, same signature you can write in the small page, because as for example, in the case of passport form, you will find a very small area where you have to sign. But if I give you a plain paper, your signature will be of your size, whatever you want, that 2 inch, 3 inch and so on. So, there is a need of normalization is becoming, and you have to noise will be there, the noise has to be removed, and after that you will be extracting the features. And once feature is there, there is a concept of learning, as I told you that your signature is varying, right. Because if I tell you that you check your 4 years back signature and current today's signature, there is a vast difference. So, that learning is required, so that most recent query signature can be used to identify yourself, and finally, you have the recognition. So, this is the block diagram, the signature you have, and then scanning and cropping, pre-processing module. Now, since the signature may be in the color space or the grayscale, there is a need of creating the binary image and normalize it. There is a learning module, feature extraction module and verification module. Finally, we will be giving the output. Here, we will be discussing what we have done, right, but there are other ways also you can think. We have taken your signature on a page, there is a box of 9, 3 cross 3. So, in 9 places you have signed, and that page has been scanned using a simple 200 dpi scanners. So, you have an image which contains the 9 signatures, and that image has been scanned using 200 dpi flatbed scanner. So, these scanners, this scanned image you have to use, and then you will be cropping the signature, 9 signatures, right, and this cropping image you will be using. So, let us see, it is there, it is visible, right, some signature is there. So, this type of page was there, and here your name, registration number, all those things we have filled, and then we have collected the signature. The problem is that you have to know this point, this starting point of the image, scanned image, and then you have to extract these signatures, right. It looks simple. If I know a priori my image, then I can easily go to this coordinate, and from there I will be looking for where I am getting the black line, black dots, and that is your starting image. That line onwards you go till this one, but it cannot exceed, these dots are known to you, because this is this 3 cross 3 image you have created. So, it is easy to crop that image, but in reality it is not the case. What happens? I have collected your signature and I have put it on the flatbed scanner. Now, it is not guaranteed that you have put it in exactly in the same place. It may be shifted, it may be tilted little. So, this image will be tilted, and as a result the starting point may be in problem, because it does the raster scanning method, reads the true raster scanning method. Even I faced, or we faced the problem, if I use it, that blank page where 9 signature box is there, and I scanned it or through Xerox machine, and then I give it to you to sign. That Xerox machine is also having some problem, because it is not necessary the page will come exactly the first page format. So, there may be some shifting operations. So, photocopy did not work. What we have to do? We have to take the printout, and that is the safe mode. You have to take original printout, and there we used to collect the data, this 9 signatures, and in that case this coordinate is registered, this coordinate is available, exactly it is available. Then you scan it. So, we got this cropped image. This is the cropped image. Initially, this is the this is the noise removal algorithm. What noise, how you will be using will very well known technique, we will discuss later on. Now, there are two components, one is that binary image, another one is the grayscale image. So, binary image, from there I can easily convert into the binary image, that one is if it is using some threshold value, we will discuss what, and then if it is below threshold value, you put very dark 0 and above threshold value put 255. So, you get a binary image, 2 color image, and then you need to get the appropriate area only, and this should be normalized also, because signature, as we have told, that even if you compress it, the structure will be same. So, you need to normalize it, and after normalization there is a scope of thinning. So, you get the thinned image. The other side I have written that whatever image you have, it is in the grayscale, and from the grayscale you determine what is the high pressure area. Everybody who signs on a paper, he has certain peculiar characteristics. Say for example, while I sign the paper, right, this is the one way. So, you observe this is a pressure I have given here, here I have given another pressure. So, extra pressure is there on your signature. Those extra pressure point is important, because this cannot be copied by forger. Wherever you give the pressure, that is you only will be giving the pressure. Now, let us think about how to remove the noise. Simple one is the median filtering technique. By now, you know what is median filtering. You take the 3 cross 3 and you obtain the median, and that position's value will be replaced by the median value, right. So, that will remove your noise. Once it is a noise free image, you need now from the block diagram I have told that you need to obtain binary image, thin image and high pressure region image. Binary image conversion is very simple. You first obtain a threshold value, and all the above threshold value you put the white, and below threshold you put it dark, right. Now, this threshold value obtaining is based on the grayscale image, right. You have to know that what should be the appropriate way of. But one thing here I can tell you that once your threshold value you have decided, that threshold value you have to use for everybody, otherwise you are in problem. Now, this is your binary image. Now, I need a simple single line signature. How can I do it? So, what technique is? There are different various techniques available. One technique is known as you move a mask, right, and if you get the neighboring pixel black, you put that instead of 2 blacks, you put 1 black. Like that you iterate it. Finally, you will be getting this type of signature, and this will give you a single line signature. So, if you get the, see you are moving 2 black, you make it 1 black, again 2 black, make it 1 black, 2 black, or make it 1. So, what happens? The signature will be becoming a thinned one, right. Now, it is in one dimension I have told, but the thickness can be this direction also. So, you have to do similar operations to get it. In that process, you may find out the signature may not be like this form, it may be like that. It may come of staircase format, but single line. So, high pressure region, as I told you, there exist some regions or some area where you have given extra pressure, that pressure you have to obtain. How to obtain that pressure? So, what we are thinking that suppose I have an image and then I reduce one layer, that I decrease the gray value by 1. Then I decrease again another by 1, another by 1. So, what happens? The dark values, very dark values will be retained after some time, and other soft values will be gone. So, in order to make it that only the very dark values you want to retain and all soft dark value you want to remove, what we have done? We have obtained another threshold value. This threshold value is dependent upon the minimum and maximum of gray values, right, of the signature area. So, what we did, the value of threshold is set 70%, 75% of the mark between the mean and max gray values, right. We obtain the minimum value and the maximum value other than the background value, mean and max, and then max minus mean, and it is 75%. That is your threshold value. If it is above that, they are not considered as the pressure point. The formula is, I know the minimum, I know the maximum from the image. So, threshold value is nothing but minimum plus 75% of max minus mean, and that will give you a threshold value. If it is less than that, you assume that this is a high pressure area, otherwise it is not. So, you have introduced now skeleton image and high pressure regions. Now, from these two images, you have to obtain the various parameters. These parameters will be defined. There are 27 parameters, and also there are two terms we will attain global feature extraction. From those parameters, you will be using the features from the global image and features from the local image. The what is global? Global is the whole image you will be considering, and local means the local, some grids you will be computing. On that grids, you will be computing the features. What are the parameters? So, one is horizontal projection, another one is vertical projection, nothing but horizontal histogram and vertical histogram. You have the black and white image, I can easily obtain the what is the horizontal histogram, and I can also have the vertical. Suppose I have this signature, I can find out, I can have an histogram, how many pixels are here, how many pixels are here, and so on, right. Similarly, vertically also we can find out how many dark pixels are there. So, I get the two histograms. Then we can obtain what is the center of gravity of your signed area. That is also you can easily obtain. We can discuss what is the formula. Then global baseline. Global baseline means the line under which that most of the pixels are lying. And upper extension line, lower extension line, middle zone, width and height of the image, and also corresponding area. So, let us see each one by one how to obtain horizontal and vertical projections. This is nothing but the simple histogram computation. Am I right? Just horizontally compute. So, you will be getting like that. And similarly, you will be getting another one. If I project it this way. So, one is horizontal, another one vertical. Now, if I know this one, I can find out very easily center of gravity. It is nothing but the x and y coordinate, which is the weighted average of this and this one. So, you know the center of gravity. Is it okay? Now, global baseline. Global baseline is nothing but which line is having the maximum frequency. That is the thing, right? Because every signature you will find that in my signature there will be line here the maximum one black values. That is your global baseline. Now, there is a possibility you may get the two large, maybe you may find this another one, this like the two horizontal containing very large values. In that case, you take the average of these 2 points and that becomes your global baseline, right. So, global baseline is the baseline. You write any Hindi character or English character, there is a baseline. So, that is your above one is upper extension and below one is the lower extension. Yes, yes, angle will come, angle whatever angle, but baseline cannot be angle. Baseline is nothing but, suppose I sign not this way, there are people they sign this way, right. Now, the baseline is that containing the maximum dark points, right. That line is rotationally fixed, this is this line.
Like some people put a straight line below this, then that will be the baseline. Like because all the correct pixels on that line.
Some people
Put this line under this, like they write the name and put a line. So
if there are people they write. This is not the baseline. No, you have to find out which area, if I draw the histogram horizontally, then how many points are there? That will be your line. How many points are there?
that is the most of the points will be the black point would be this.
Need not be, need not be, need not be, need not be. See, generally such a long line very few gives, and even that long line is there, that will be tilted one. So, you will not get, am I right? Generally people give dot dot. So, dot dot that will come in as a high pressure region. So, the upper extension is nothing but you have the histogram, you got the baseline. You got the baseline and you get the, if I draw the something like this will be getting, you will be getting like this, right. If I do the approximate curve and you have the curve of the horizontal projection and approximate curve of the same projection of the baseline. So, you have to get that this is your upper extension line, this is your baseline. So, if you draw the curve, you will get a line, here it is coming. So, this is your upper extension, this is your lower extension line. So, if I know this upper extension line, these 3 lines you can, in Hindi characters, you have the matra, right. Above one is upper, this is one line and this is another line, below also there are some dots are there, right. So, that is the baseline is the center one and then upper extension line and lower extension line. So, that is the things we define, same idea we have considered. And this zone is known as the middle zone, that between the two upper extension line and lower extension line, whatever area is there, that is your middle zone. This middle zone contains most of your signature, am I right? Now, this middle zone will give you several informations. Now, can I find out width and height of your signature? You have the histogram. From this histogram, I can obtain the width, I can obtain the height, am I right? Now, there may be some noise. You may find out in your histogram, you may find the histogram is like this. So, these are maybe noise, right. So, in order to obtain the width, I do not need this information, I suppress that some number, some here it is considered 3 pixels, but some small number, if you find that you do not consider that, you consider this is your width. Similarly, you have the height, sorry, this is height, this is width. So, you do not have to consider this one and this one, right. So, width and height is known to you. If I know the width and height, I know the area. So, how many black pixels are there, right, which has not considered those 3 pixels, 2 pixels, those noises. Now, you have obtained the feature points. What are the feature points? Global baseline, upper extension, lower extension, width, height and area, right. Now, these parameters are used to obtain the features on the whole image and also on the local area. Local area is nothing but the grids we have created. One is with the above extension line, below extension line, below above baseline and so on. So, I have the 3 parts. One is upper extension line above, another one is lower extension and another one is the middle zone. These 3 regions are there. For these 3 regions also local feature point I can extract. Now, what are the feature points? So, there are total 27 feature points. I know width, I know height, I can obtain the ratio. Why I am obtaining the ratio? I have to normalize. Remember one thing, the signature size may vary, right. So, that is why to normalize it, we have done the ratio between the width and height. Then we can obtain, we have the center of gravity x and y and we know the height, we just obtain the ratio x by height and y by height. Then normalize the area of black pixels, that means width and height is there, but what is the image size? Based on that you can find out the normalized area, normal area of black pixels. Then this can be considered as a graph. I can find out the number of connected components. Consider this signature, you observe that this is one component, this is another component and this is the third component, right. So, number of connected components is also important. If you start forging somebody else, you will find that the connected components or number of connected components is different. So, I can easily find out the number of connected components. You have the global baseline, you know the height. So, I can obtain the global baseline by height ratio, upper extension line to and height ratio, lower extension to height ratio, center of gravity. Now, I am considering that high pressure region. So, you can obtain the center of gravity of the high pressure region to the height ratio and area of the black pixel in the high pressure region to the total area of the black pixel, that also you can obtain, and number of cross points of the black pixel. This is another thing what we will be discussing, that you have to find out the number of cross points to area of the black pixel in the thin image, that is also ratio. Now, what does it mean? Number of cross points. If you see the signature, there are some crossing points. So, for example, in my signature, so there is a crossing point, here there is a crossing point. Similarly, you will find there is a crossing point, there is a crossing points, right, crossing points and so on. So, this how many crossing points are there? So, in any signature, you will get the several such crossing points, right, and also you can find out the number of end points. In your signature, there is an end point, here one, here one, here one, here one, here one, right. There are several end points. So, number of end points also you can find out. So, number of endpoints to the area of the black, again the question of what every time we are considering the area is my base thing, because I have to control my size. So, that is why. And then slope of the thin image, you have the thin image, can I find out the slope of that image? Slope of the image you have to find out, because the person who signs always signs tilted manner, he always will sign in the tilted manner only, that is the regular practice. Trace, then trace to area of black pixel in the thin image. So, exactly thin image also you can find out what is the total number of black points, right. Same whatever things we have considered, that also for the three regions of above upper extension, below lower extension and the middle zone, you can find out the coordinates, center of gravity, ratio of center of gravity coordinates to height, ratio of pixel count of individual section or to the pixel total pixel count of the image, ratio of the baseline positions to height of image in the three horizontal sections, because first upper extension, lower extension and middle regions. So, those ratios you can obtain. So, you got the 27 feature points. Now, these feature points will be used for your matching purpose or decision purpose, right. As I told you, the signature is varying, right. So, can I use these 27 features constantly? That will be a risky environment. So, what we do? We have to learn every time. Whenever you sign, we obtain the mean and standard deviation with respect to the whatever knowledge you have. So, given the previous 9 signatures mean and standard deviation of your signatures of different features, for against each features I will keep the mean and standard deviations. You have come and I will and new signature you have given, I will modify my mean and my standard deviations, I retain it. So, whenever you give a signature, I check these feature points whether your feature, each feature is lying between that x bar plus minus 2 sigma or 3 sigma. If it lies between that, you tell that these features are matched, right. So, with this idea, we can have the distance formula 1 by n summation C I x I minus m I square divided by root mean square, basically sigma square, and then you take half, right. Where n is the total number of features, which is 27, C I is the weight you want to give on the ith features, because all features are not equally important, Some features are having more power, more dominant power compared to the other one. So, some weights you have to assign against each feature points. Xi is the ith feature point, you whatever you got, Mi is the mean of ith feature point obtained from your previous data, and sigma I e square is the variance of your variability of your ith feature points from your old or training set. So, this is the definition. So, once you know this one, so can I take the decision? Obviously, this after that what will happen, that you get some value, because what you will be getting, distance is equals to root mean square, some value you will get. Now, this value, if this value is less than some threshold value, you will be telling that it is matched, otherwise you will tell it is not matched. Now, what is the threshold value? How to compute the threshold value? Threshold value we have obtained z into square root of n. Square root of n is the number of threshold value, n is known now, number of feature values, feature points, which is 27. So, square root of 27 into z, z is some constant. Here in our case what we observe, or in Indian scenario what we have observed, that we have put z is equals to 1.75. So, 1.75 into square root of n is your threshold value. If it is less than that value, you tell except the distance is matched, otherwise you tell distance is very large. So, you are rejecting, right. This is all about, I think this is all about how to estimate the value of Ci. Yes, Ci is the weight assigned to each of the parameters. Now, you will be observing these Ci values will become, because sum of Ci will be 1, let it be clear, right. Now, you may not get all the features on your signatures. Some features is you will find that it is say high pressure regions, right. Now, less number of high pressure regions will have the poor probability of matching. Am I right? If I have more from your signature, if I get too many high pressure region, high pressure dots, so you get extra parameters, but if I have only 2 dots, 2 high pressure dots, I will not get. So, those issues you have to take into account. Is it okay? So, what happens that some of the feature points you will find that they are present always, they gives always uniquely. Some of them are, you will find that they are routine, everything. So, you give little less weights. So, this Ci will be computed based on that idea, right. So, these are all through training only you have to gain knowledge. Is it clear?